In this video, we are going to talk about the different circuit components, connections, and the code that is being used for making this project. And in the second video, we will see a real life working prototype of this model. So let's begin. For this project, we have used one Arduino Uno board, a breadboard, an ultrasonic distance measurer, and a servo motor. Now, talking about the different connections, the trigger pin of this ultrasonic distance measurer is connected to pin 4 of the Arduino Uno board with the green wire. The echo pin of the ultrasonic distance measurer is connected to pin 5 of the Arduino Uno board with this red wire. The VCC pin is connected to this line, which is in turn connected to the 5-volt pocket of the Arduino Uno board. The ground pin of the ultrasonic distance measurer is connected to this line, which is in turn connected to the ground port of the Arduino Uno board. And talking about this servo motor, the signal port of the servo motor is connected to pin 3 of the Arduino Uno board using this violet wire. The ground port is connected to the ground port of Arduino board through this line, and the power port is connected to the 5-volt power port of the Arduino Uno board using this line. Now let's quickly go through the code that has been used in this Arduino project. First of all, we have included servo.h library file because it contains all the servo functions that we'll be using in this project. Then we have named this servo as DIY servo. We have connected the trigger pin of the ultrasonic distance measurer to pin 4 of Arduino and the echo pin to pin 5 of Arduino. Then you have declared few variables like distance, duration, centimeter for measuring the distance using this ultrasonic distance measurer. In the void setup, we have connected the signal pin of the servo motor to the pin 3 of Arduino. Then we have initialized the trigger pin as output and the echo pin as input. Then finally we will be running the loop. Now the thing is, this ultrasonic distance measurer sends waves of around 40 kHz from this transmitter mentioned as T and then receives them through this receiver mentioned as R. In this loop, we will be measuring the time taken for transmission between the transmission and receiving. Then we'll be converting the time taken to get the distance of the object. Now if the distance is less than 30 cm, then the DIY servo motor will turn 180 degrees and with a delay of 3 seconds. Otherwise it will just stay there for 50 milliseconds and this loop will continue. Let's see a quick simulation of how this project will basically work. In the next video, we will be seeing a real life working prototype of this project. So I have started the simulation, and as you can see, the distance is 51 cm. When I will bring it to lower than 30 cm, then the motor should rotate. So the motor has rotated and the dustbin has opened. Now when I bring it to more than 30 cm, the motor has rotated and the dustbin has closed. Thank you.